Q8731. The presence of fuel stains around a fuel nozzle would indicate A. Too much fuel pressure. B. Excessive airflow across the venturi. C. Clogged fuel nozzle. The correct answer is C. When a fuel injection nozzle becomes clogged, it can cause fuel to escape through the air bleed holes located on the side of the nozzle. This results in noticeable fuel stains appearing on the cylinder head surrounding the affected nozzle. The presence of these fuel stains serves as an indication that the nozzle is not delivering fuel properly and requires attention. It is important to address this issue promptly to ensure proper fuel flow and prevent potential engine performance problems or fuel system malfunctions. Q8732. What should be used to inert an integral fuel tank before attempting repairs? A. CO2. B. Water. C. Steam. The correct answer is A. CO2 is commonly used to inert fuel tanks as it is non-reactive with fuel and air and can effectively displace oxygen, which reduces the risk of fire or explosion during repair work. This is typically accomplished by flooding the tank with CO2 until the oxygen concentration falls below a certain threshold. Q8733. What should be used to remove flux from an aluminum tank after welded repairs? A. Soft brush and warm water. B. 5% solution of nitric or sulfuric acid. C. Mild solution of soap and warm water. The correct answer is B. After completing the welding process on a tank, it is important to promptly clean both the inside and outside of the tank. This can be done by washing the tank with generous amounts of hot water and allowing it to drain thoroughly. Subsequently, the tank should be immersed in a solution of either 5% nitric acid or 5% sulfuric acid. This acid bath helps to remove any residual contaminants or impurities from the tank surfaces. It is crucial to follow appropriate safety precautions and guidelines when handling acids and to ensure proper disposal of the acid solution after use. Q8734. What method would be used to check for internal leakage of a fuel valve without removing the valve from the aircraft? A. Place the valve in the OFF position, drain the strainer bowl, and with boost pump on, watch to see if fuel flows to the strainer bowl. B. Remove fuel caps, turn boost pumps on, and watch for bubbling in the tanks. C. Apply regulated air pressure on the downstream side of the fuel pump and listen for air passing through the valve. The correct answer is A. To check for internal leakage in a fuel valve, follow these steps. 1. Place the fuel valve in the OFF position. 2. Ensure that the fuel strainer bowl is empty. 3. Turn on the fuel tank boost pump. 4. Observe the fuel strainer bowl. 5. If fuel flows into the previously empty strainer bowl, it indicates that the valve has an internal leak. This procedure helps detect any internal leakage within the fuel valve by observing if fuel flows into the strainer bowl when the valve is closed. If such leakage is present, it may require further inspection and maintenance to address the issue. Q8735. Why are jet fuels more susceptible to water contamination than aviation gasoline? A. Jet fuel has a higher viscosity than gasoline. B. Jet fuel is lighter than gasoline. Therefore, water is more easily suspended. C. Condensation is greater because of the higher volatility of jet fuels. The correct answer is A. Jet fuels indeed have a higher viscosity compared to aviation gasoline. This higher viscosity has an impact on the behavior of contaminants, particularly water, in the fuel. Unlike aviation gasoline, where water tends to separate and settle at the bottom of the fuel, jet fuels with higher viscosity tend to keep contaminants suspended within the fuel. This means that water and other contaminants do not easily separate or settle out, but remain distributed throughout the fuel. As a result, proper fuel management and filtration systems are necessary to ensure the purity and integrity of the jet fuel used in aircraft engines.